How many of you have heard of serverless? Good. Another new hotness. So we're bringing a couple of the core Red Hat folks that are working on these technologies here to talk about serverless in relationship to Kubernetes, Knative, Istio, and a little Kiali in there too. So if at the end of this next segment, you ought to know what all of those are. And if not, you can ask them questions in the AMA section.
Thanks for the introduction, Anne. My name is Matthias. I'm with Red Hat, currently working in the messaging team and focusing there on Knative eventing part. And with me is Lucas.
My name is Lucas Ponce. I'm also fully Red Hat engineer, working on Istio and Kiali technologies as well.
And we're here to talk about the state of serverless. One of the big topics there recently is Knative, and we have basically some Knative introduction for you. Knative under the covers builds on top of a lot of existing primitives from the Kubernetes and Istio communities, and you will learn how Knative is actually leveraged in that in order to make application development simpler. So serverless is not just limited to functions with Knative, it's like full application driven. And the first part of the talk is actually done by Lucas. He's giving you some details about insights on Istio and the visualization part with Kiali.
Okay, thank you, Matthias. How many of you are using microservices in your organization? Okay, and how many of you has implemented service mesh actually today? Okay, cool. So, okay, why service mesh? Let me just do a quick introduction of what we are doing. So now industry is moving from monolithic application into microservices that are running to containers, right? This is quite clear. But now wait a minute. What is happening? That with this new explosion of microservices, we are creating a lot of new components that need to communicate each other over the network. Just to give you an example, in one of the meetings with some customers in my country that is planning to deploy a new architect, is telling us that, okay, we are planning to move from 300 applications in our systems to more than 7,000 new microservices. So that is a lot of new communication between components. And okay, I'm a developer, so what I need to do? What is going to happen now? How I'm going to communicate these services between them? When I was working in my application server, the application server was responsible to inject one services or one components into my application. I didn't need to care. But now you are telling me, hey, my microservices need to talk with each other microservices. I need to add more try-catch blocks of code to protect my component to what happened when the microservices I'm working is not working, is failing, on how to do that. At the beginning of the early adopters of microservices, big internet companies mainly has developed ad hoc solutions. So some companies have developed some specific framework for smart routing. Smart routing means, okay, what version of microservices I need to invoke? Can I change that dynamically? Can I change that with some kind of conditions and so on? And other frameworks that these companies have developed and these new patterns have been created is how to do with the fault tolerance in the microservices, to do more policies for load balancing, or to introduce new concepts like circuit breaker. What is a circuit breaker? Okay, it's the concept that, okay, if I have a services A, which is calling service B, service C, and service D, but the service D is failing, I don't want to have all the pipeline blocking and delaying. So I want to make, as soon as possible, to notify to service A that should fail in order to not create problems on my services, right? And here is when the service mesh enter on stage. Okay. The idea is that in the past, we need to populate our service or deploy our services with these old frameworks. And the idea of the service mesh is to provide, like in our container platform, to provide to OpenShift an extension that can deliver all these features in a real transparent way. And that is Istio. Istio is an implementation of a service mesh. Basically, it works with the concept of proxy sidecar to all my pods. So every time that I make a deployment, a new sidecar, a new container with a proxy is going to be collocated in my pod. At this pod, this proxy, which is Envoy, the implementation is based on Envoy, is going to capture all the Envoy and Envoy traffic to my pod. It's going just to apply the traffic enforcement to apply to that. is going to communicate with a list of components which is going to be responsible, for example, for the service discovery, for the traffic rules, okay, how to report the telemetry, how to report the security, okay. This is how we are going to implement our service mesh. In another picture, how this works is in my pods, we are going to have our proxy, and our proxies are going to be communicate with the core components of Istio, for example, for Pilot, just to collect all the configuration that I'm writing, and Pilot will be responsible to deploy all the configuration of my pods to build the traffic routing between all the proxies. Okay, Mixer is going to collect all the enforcement and the telemetry for the components. Citadel is going to be responsible for the security, the encryption between all the communications. Galay is going to check all the configurations, and another component like Kiali is going to be responsible to the UI of the observability. Just going a little bit deep about the concept of Istio networking, Istio works, or Service Mesh works with two main objects, okay? The first gateway is how to expose external services to, how to expose my Service Mesh services to the external, okay, to external traffic. The next concept is about the virtual services, is how I can apply smart routing traffic into my system, how I can say, okay, I want to, the service A is going to communicate with version 1 of the service B in certain scenarios, but in service B in other types of scenarios. Destination rules are going to implement the fault tolerance policies, what happened with the load balancing, with the retrace, with the delays that I can add to my pods, or what happened, how to implement a circuit breaker between my services. And the service entry is going to include to the Istio capabilities all the external services that we are going to call from all internal services from the external plan. With this component, we can build, for example, these traffic routing patterns, like for example, to the new Canary deployment, that's a Canary deployment, is the ability that, okay, I can I can deploy in a transparent way a new version of my service. And with Istio, I can I can do a smart routing in order to limit who is going to talk with a new version. For example, I can just limit the new version to a certain group of users, and I can validate if the new version is correct, is good, and then I can roll out or completely deploy the new version into the new system. Also, with Istio, we can apply another typical pattern of A/B testing or A/B deployment. When I can just put a new version, I can compare how it works one version with the other. Okay. And what about the observability? We are telling that, okay, the microservices, we are adding new complexity. We are adding more and more services. So it's clear that we need, it's key to have some kind of utility where we can see what we are doing. So this is what the Kiali project is doing. Kiali is a UI that now is part of the Istio, like a new add-on that you can install in your service mesh. And basically the goals of this application, this project, is for one side is to tell you what your microservices are doing, how are they communicating, what is the health between them, how it is focused on all the telemetry aspects, okay? And also to give you the ability to explain why. How is configured my service mesh, okay? Where I can spot potential problems, or where can I detect some kind of a scenario that I need to fix, okay? And that's it.
All right. Yeah, the second part of the presentation is covering Knative. A few hands were up when the term serverless was there. Anybody already using Knative? Heard of it? Planning to adopt it or evaluate it? Okay, I guess I have something for you then. So yeah, what is Knative? Knative is one of the new serverless projects there. It was launched in summer by Google, and Red Hat is one of the participants that are working with Google and the upstream community on driving Knative forward. It's based on established industry standards like Kubernetes as the infrastructure layer. And it also leverages tools like Istio for routing of the different services. And you will see later in action how that actually works. So it's something with the mindset of bringing the experience from Kubernetes more for the application developers as well, that you can basically run your serverless applications on top of Knative. Knative itself has three main components. There is a build component. The good news here, it's not yet another build tool. It's actually more a standardized or more common API, which has hooks and configuration mechanisms into different build templates. So when you use the Knative build facility, you can actually trigger your Knative build, and under the covers, there's adoptions that, for instance, make sure that your container is built using OpenShift source to image. So the community has a bunch of build templates up there in the repository, for instance, Builder and others there as well. Another interesting component here is the serving part, and the serving part is really a simple way to deploy your applications to a serverless platform. And the term serverless here really also contributes well to the concept that your application can scale to zero. We will see that later in action as well, that serving has an autoscaler and an activator. So when there is no traffic, after some time, your HTTP server application is being tiered out. And when there is new traffic coming, then Istio knows, okay, there is some traffic going on to that particular URL, and then it's reactivating the particular port for you, and then your application is happy to answer the requests there. And the last but not least big thing there in Knative is the eventing facility, which is basically some common infrastructure for allowing you to build modern event-driven applications on your serverless runtime. I have a demo later, which basically walks you through an end-to-end deployment where data is triggered from a data source and it is routed to different services. So with Knative eventing, you can build your own kind of data pipelines or data workflows. As you see here, in Knative, there is the event, there is the type, in Knative eventing, there's the API type of a data source. So this can be something that you either implement yourself or you use existing sources, event sources from the community. It also has the feature of a container source, so you can run your own images. So this is where you, for instance, would call into your third-party system and then read data and forward them to an HTTP service. So, for instance, you could write your own container source that's reading topics from Apache Kafka, and then the container source will run your own image for you. And the image basically reads every message from Kafka and is then transforming them into cloud events and is sending them to a construct in Knative that's called a channel, which represents the green lines here. And then once you subscribe a service, which is a Knative serving, so at the end of the day, that is an HTTP server application. So once you subscribe your service to the particular channel, then there is a Kubernetes controller running inside of Knative eventing that is reading all of the messages from your channel and is sending that to the particular HTTP application that we have there. So now you can then use this mechanism to build some fancy pipelines there. For instance, my first service here is reading some data, and then it is doing some transformation, and it is returning some filtered reject. And returning in this case means you basically send an HTTP response to the invoker. So and then Knative, the subscription controller that manages the subscription of this service to that particular channel, knows how to deal with that. When a service does return a HTTP request object, for instance, a JSON document that is a cloud event, you can then define in the subscription that the return value of that particular service is going to a different channel. So, and then you can have multiple services subscribing to this channel. And then you can basically continue a pipeline where you route events through a more complex processing engine. And at the end of the day, you update with the last service. This one is not returning a result. You can then update the database. or you can also directly go to the database if, for instance, this route is more for short-term analytics, and then just doing yeah, I'm fine with it. I store my results in the database. So you can already, with Knative primitives that are there today, you can already build some complex data pipelines where you basically run Knative serving services. These are the purple one boxes, and with a connection to a database or data source, actually, with Knative channels. All right. I have a little demo prepared here. Is the screen somewhat readable? Silence is acceptance, all right. I have installed Knative through an operator that we have, and it has a lot of stuff installed here. So it comes with the Red Hat Service Mesh, which comes with Istio, which also comes with Kiali for visualization. It has a few Knative namespaces, Knative Build, Knative Eventing, and Knative Serving. So, and I am now in my default project. I'm going to watch my pods. Earlier, as a preparation, what I did before is I was testing a little bit, and I was deploying a service, which is an HTTP application. So that API has been used to describe my my application, basically, and currently none of them is running. So we can take a look how that actually would go with the YAML. So this is a definition of a Knative serving service or application. So the main API here is serving Knative something, and then it's the type, it's a service. I give it a name, and this code is named dumpy because it's just a Golang written message dumper. So every request that goes into the HTTP server is dumped on the console. I also have some more information here inside of the specification. The interesting part here is that I have to provide a container image in my setup. So I was stashing a previously built container on a registry, and I'm using that. I could have also included here some information about the build system with Knative. So Knative could have gone out with the Knative build and the actual behind plugin or adapter for OpenShift source to image. It would basically read the source code repository that we have for this very trivial HTTP server application from GitHub, build it and turn it into a container, and then automatically provision it. So I don't have to do anything with the markup here now. What I'm doing here is just an invocation, and you already see the Knative autoscaler coming in place here. So I have a curl request, and whenever my pod has been provisioned and is completely initialized, then it is in the running state here, and then you get back an HTTP response. So Knative, the activation mechanism was basically ensuring that the pod gets reactivated. I can do some little more load. So the endpoint is so fancy, it has this health endpoint, which is printing out Red Hat. Now, I can show you this in Kiali, the visualization. So what we see here is because the pod of my dumpy service was activated using the Knative serving activator. So it is sending the request in there, and then my curl, because I was using a special header with the actual resolved name of my proper service, from the Istio system, the traffic gets routed to the particular endpoint. And this is the view of what's going on behind the scenes, where Istio is taking care of the routing of the traffic to my application that's running there, as well in conjunction with the Knative primitives for the scaling part, in this case, the auto-activating. All right, I will pause this now. If I would just stand here for 5 more minutes, what we would see is this guy is terminating because there's no traffic anymore. So it's scaling automatically for a 0 size of deployment. So that's one of the models of serverless, pay as you go. So that's also baked in. And as you saw, the lines for describing your application is pretty trivial compared to what when you do it like on by yourself with Kubernetes and ingress routes and stuff like that. So that's a very nice and more developer-friendly API, and that was one of the motivations giving developers powerful tools here. Okay. We don't really want just some dumpy service that is manually invoked. I was talking about the eventing workflow earlier. where we had some event source, and event source is connected to a channel. And the channel at the end of the day is again an HTTP channel. So in order to get a full pipeline, I need to provision or apply a channel here. The YAML is also very trivial. Let me give you the YAML. So the channel has a name, it's called test channel, and it has a reference, and that's required. It has a reference to the actual type of the channel or cluster channel provisioner. In this case, the channel is an in-memory channel. In the upstream community, there's also different channels, for instance, with Apache Kafka. That means basically the channel, which is again an HTTP server, everything that's reading in is stored in an Apache Kafka topic. And whenever you later subscribe your application, your service, in our case, this dumpy guy, whenever that is subscribed to the particular channel of test channel, then the Knative eventing facility has a certain dispatcher that's running there and making sure it reads, using native Kafka protocol, it reads all of the messages from that particular Kafka topic and is then again doing the transformation to cloud events and sending them over HTTP to my dumpy service. So I have the channel now running. What's missing? My source is missing. The source is also not too complicated as, oops, that was the wrong file. I fooled myself. The source itself is also not too complicated. I said earlier that there's different types of like pre-existing controllers. For instance, there's GitHub source that's like a native implementation, and there is some more convenience one. There's a container source. So that basically allows you in the specification to provide some image. And in our case, we have a WebSocket event source, which reads from a public URL on the internet. That's something in the University of Newcastle. They have some meter and sensor data. They have some devices deployed across the entire university. And these nice guys are very nice that they provide all of the data as a publicly available WebSocket stream. So what my event source here is basically doing, if you would take a look at the source code there, you see there is a Golang application running that does a WebSocket connection, and every message that it's getting is translating that into a cloud event and is sending it over HTTP to a channel. And in this case, we reference the sink to a particular channel, and that's the test channel that I did provision before. Now, because this is not cluster internal, I need to provide some Istio routing routes. I need to say Istio that I'm going outside here. I'm telling it it is port 443, and I tell it it's the protocol HTTPS. Sure, I said WebSocket before, but WebSocket is established from HTTP. So it's a secure WebSocket connection that's established from an HTTPS upgrade. 101 is the response code, and then you're basically on WebSocket. So that's what you need to do there. We can now apply these Istio network rules. And once these rules are there, I'm fine and basically provide my, my data source here or event source. What you will see is that there is another pod coming up here, which represents the container that's referenced in there, which basically does the connection to the WebSocket URL and does the transformation and sends them to a sink. And the sink in this case is an HTTP channel, which is not backed by any powerful messaging system. It's one of the default implementations there, the in-memory channel. So last but not least, what's missing there is that I need a subscription in order to get some data into my dumpy service here. So let's see the logs of that particular container. There's 3 containers running in this pod, and there's one that's the user container, which is actually my code. The other ones are injected by the framework. And what we see, there's no fancy cloud event here. It's just vanilla HTTP here. And what we actually see here, I was talking more than 5 minutes, so this guy is now idle and terminating. It was not receiving any traffic, and now it is gone. Okay, cool. That's exactly what I wanted. So let's take a look at the subscription. So while I'm talking, the event source is reading WebSocket and giving it to a channel. However, I have no connection now between the channel and my application. That's what I do with a subscription. The subscription has basically, in this case, two interesting points. One is a channel. So I say, I'm interested in subscribing my application called Dumpy to the test channel here. Let's do that. Now the subscription is created, and then some Knative controller goes in and is doing the relationship between the particular service and the particular channel. I was talking a lot, and while I was talking, it was writing to the channel, but there was no one receiving the data. So a lot of messages have been buffered up there. That means the autoscaler is now kicking in because it doesn't want your application to go dark, so it's bringing a lot of these pods up there. It will relax down to 1 or 2 different pods because, yeah, the amount of the messages when you are subscribed to it live is not that bad. Let's take a look at the logs, how they now behave here. I go with the first one. Again, the user container, oops, user container. Okay, here we can now see that I have actually different output here. What you see here is some metadata for the cloud events as response headers. So I have the spec version 01. I have some event ID. I have some timestamp for it. I have a WebSocket event as a type of it. And I have some source, which is triggering that one here. And now what you see here, Knative did realize that there is not that much traffic. I don't really need 5 or 6 different deployments there. I'm just fine with one particular instance. I'm able to manage that. If for whatever reason this WebSocket stream again goes crazy and it is hammering and pumping too much data into my channel using the event source, then the autoscaler comes in again and you will get a much more pods. Okay, how does this look visually? So what we see here is that I have a source, which is this guy. So that's my event source, right? It reads WebSocket and is sending the values of the read messages with HTTP to a channel. And the channel is this particular guy. And the channel has a dispatcher, right? It has a dispatcher which knows, okay, there is a message service interested because it's subscribed to me. And then the dispatcher is basically reading the message from, in this case, the in-memory buffered persistence or persistence, pseudo-persistence, and is then routing them forward to my HTTP application here, which is the Dumpy HTTP server. Okay, now if I delete the subscription again, and I would talk here for 5 more minutes, we would see that this will also disappear because now when the subscription is removed, the messages from the event source are still distributed to the channel, but there is no subscription anymore. So that's persisted in the channel until you basically resubscribe to the channel, and then the data is again routed to the service. So yeah, and this demo is using, for simplicity reasons, is using an in-memory one that's default deployed there. We also have on our GitHub repository some instructions on how you can actually get Strimzy. That's the Red Hat project for running Apache Kafka on Kubernetes and OpenShift, how you can use the Strimzy cluster inside of OpenShift and connect that with a Kafka channel that's also available in the upstream Knative project. And with that, I guess I go to the final slide, and I say thank you for your attention.